Hello there and welcome to Text Classification with Python. My name is Valentine and I'll be your instructor. This course will follow the following structure. So we'll get started learning about the learning outcomes. We also get to learn about what is text classification, why do we apply text classification, as well as when we apply text classification concepts. The idea here is that you will get a macro view of what text classification entails. After that, we will go through a reading and quiz section where you will go through some already curated reading that we have prepared. And this reading should give you some in-depth idea of what those text classification concepts that we have covered entails. This will also serve as the notes that you will need for this particular course. After going through this document, which you will take about 10 minutes, 10 to 15 minutes to cover, you will be required to go through this quiz, which will assess your understanding of those particular concepts that we have talked about. The idea here is that you will have gained a good understanding of the text classification concepts and be ready now to undertake some practice work. Now, once we have finished through, once we have gone through that section of reading and a quiz section, we'll then go into a practice session where we will use Python, the Python programming language, to apply those text classification concepts that we'll have gotten through. And the idea is that we'll go through this practice notebook that we will get to share that will contain just different text classification techniques that we can be able to apply whenever it comes to just generally working with Python. Aside from the examples that we will go through, we'll also provide you with just quite a number of challenges that will help assess your understanding of the concepts, that the text classification concepts that will be introduced to you. We'll also provide a solution notebook to just give you some good idea of how you would have alternatively gone about those particular concepts. And you can use this as just a way of just checking your answers to the solutions. Once we have finished going through the practice session, you'll then go through a project, which is part of the next steps. And in this particular project, the idea is that you're going to apply those concepts that you have learned in a real world context and be able to get to see how you are able to apply those skills that you have gained in a real world setup. So this project will involve just going through a few questions. Well, actually a question, but we have provided a guiding notebook that will also just help you to just go through each and every step that it takes to undertake this project. Like for example, the metric of success for this particular project would be to build a classification model with an accuracy of at least 85%. And we'll have already curated some code that you may not necessarily need to know for this particular work for this particular course. So the idea here is that you should be in a good position to just focus generally on some of the techniques that we will have learned in relation to text classification. After that, we'll also provide a project solution that will just give you a good idea of how you'd have alternatively gone about the project. So by the end of this course, the idea is that you should have a good theoretical as well as a practical understanding of text classification concepts, and you should be now prepared to undertake text classification projects in the real world. So let's get started. All right. So by the end of today's session, you expected to, or by the end of this course, you expected to have achieved the following learning outcomes. You should be able to understand the concept of text classification. You should also be able to understand the importance of text classification as well as perform text classification to group data into different categories using the Python programming language. So what is text classification? So this is a process that involves assigning categories to text based on its content. Um, you can think of this type of task as more similar to what is referred to as classification when it comes to machine learning model, but now focused solely when working with textual data. So sometimes we might want to maybe predict whether tomorrow will rain or not. But the data that we want to rely on when we are training a machine learning model might end up being just data that is textual in nature. So, in such a situation, then we might want to build a text classification machine learning model that would again process or would assign categories to text and be able to make some sort of prediction. So text classification just involves making some prediction based off textual data. And in such a situation, the prediction that you're making would be categorical in nature, or have categories, whether it's going to rain or not, as an example, or whether a particular article can be organized into topics. Maybe you might have some topics or categories, which are just categories, and you'd want to categorize articles into those topics. Then text classification can be important in that concept, in that context. You could also have support tickets, so content in relation to support tickets, and then you could use a text classification model or to be able to assign a urgency category for the support ticket that needs to be addressed. So you could also have some chat conversations that you also would want to possibly organize by language. Maybe your customers in an e-commerce site are across, come from um, different countries that speak different languages, and they're providing maybe they have questions in relation to your product, and you would also want to direct specific chat conversations to the respective persons who might understand that language. Then in such a situation, then um, text classification would be important. So why is text classification important? So starting off again, we could end up performing text classification manually, which would mean that we might end up just looking at the data that we need. So if we have a new maybe support ticket, which could be a question by a customer, and we might want to categorize that to either highly urgent or not urgent, then we could decide to do that manually, like look at the support tickets, then assign that manually. But instead of doing that manual task, we might decide to create a text classification model to just automatically be able to do that. So whenever we have lots of support tickets, maybe hundreds of support tickets, or even just maybe tens of support tickets generated, or every maybe every minute. Instead of having someone to be able to do that, you could build a text classification model that does that particular task automatically. So again, it reduces the time for that particular task to happen. On the other side, in terms of real-time analysis, again, when you have lots of data that comes in real time, and in order to be able to make decisions right away, and which is usually one of the aspects of real-time analysis, why you'd want to undertake real-time analysis. Then in such a situation, real-time analysis can be important to just enable you to in such a situation, text classification can be important in order to identify just critical information and take action the right way. In some other situations, you might want to ensure that you have some consistent criteria in how you're classifying just different pieces of text. Majorly because if you do that manually, and when that particular task is done by humans, there's a risk of errors happening. Some records might be misclassified, others might end up in the right bucket or in the right category. But to just ensure that errors that are human prone are also taken into consideration and are not are not considered during text classification, then you could end up creating what are called text classification tasks or models to be able to perform that particular um, to perform that particular task. So why is text classification important? Scalability. Whenever you're considering issues when it comes to scalability, real-time analysis, or inconsistent criteria, whenever you want to ensure that you reduce errors in the classification of tasks. So how does text classification work? There are two approaches that you could end up performing when it comes to applying this concept of text classification. One would be to use rule-based systems where you create programs that identify, say, semantically relevant elements in order to classify whether a piece of text belongs to one category or another. So, for instance, you could decide to build a software or just write some piece of code that checks for whether certain keywords within that piece of text exist, and then it can then associate that particular piece of text with a category that is associated with those keywords. So for instance, if you are trying to if you want to classify articles into sports or into politics, then you might want to create a piece of code that checks for just keywords associated with politics or keywords associated with sports. And then if an article has keywords associated with those particular topics, then the relevant category, that text is assigned to that relevant category. So that's one way, but sometimes it may not be the most efficient way possible, especially when you are looking towards just precision matters, ensuring that you have a good understanding of you have a good accuracy rate. If sometimes you might have maybe keywords that overlap, both keywords for both of the different categories appearing in the piece of text that you want to classify, and that can be an issue. So you might end up using what are called machine learning based systems, where you use what are called machine learning models, which are just complex mathematical functions that enable you to just be able to make those classification tasks a bit more accurate. So you could end up using what are called machine learning algorithms, such as the naive Bayes classifier. Could use decision trees, random forest. You could use GBM classifiers. There are quite a large number of classifiers that you might end up using. And in such a situation, you would end up actually automating the task. But one thing to note with machine learning based systems is that you need to have some data already that would help you to be able to, especially when it comes to working with those algorithms. So that data, you would need to use it to train that machine learning model to understand what particular text should be classified to a particular category. When it comes to text classification steps, these are the steps that we normally take. So we start with loading our data, the one that we want to use to train our model, and then later create that model. Then we go to exploring the data. So in an effort to prepare that data for training, we need to explore it first to understand it, then prepare it. That means we perform text cleaning, text feature engineering techniques, whether it's creating new data, deleting new data, etc. Then once those first steps are complete, then we would continue to now creating our models. So could consider creating naive Bayes text classifier, or support vector machines, or logistic regression classifier, etc. Once we have created those models, then we can decide to optimize them by applying what are called hyperparameter tuning techniques, which we have also covered in another course. So you might also see some of the prerequisites for this courses, model optimization or the hyperparameter tuning is one of those particular courses that you might maybe want to also explore later. Then once we have done that, we can deploy a model and then continue to maintain it. So those are just the steps that we will take also during our practice work to just apply text classification or to create text classification systems or models that will allow us to be able to perform text classification with ease. Now, there are various tools that we can use when it comes to text classification. So we, at the very basic, we are going to use the basic libraries when it comes to working with Python. That is pandas, NumPy, matplotlib, or Seaborn. Those are just data visualize. Those are libraries that we can use for data manipulation, for performing scientific computations, or for even visualization. So once we have used those libraries to just read the data, explore the data, we can then more specifically use what is the Natural Language Toolkit library, which is a library that we can use to perform text classification and also perform some text cleaning tasks. So we can use this particular library. We can also use another library called Sparsy that allows us to also be able to perform text pre-processing tasks in an easier way. And thirdly, we can also use sklearn that provides us with a variety of machine learning algorithms that we can be able to build, use to build machine learning models. So those are the key tools that we can use when it comes to performing text classification with Python. So yeah, so that's it up to this particular point. The next step that we're going to need is just to go through the reading and quiz that we have provided. And this particular reading, which we have provided, will contain just more details with regards to the mentioned concepts. And this should just give you a good understanding of those concepts. And then once you have done, once you're finished going through this reading, you can go through this quiz, which will just assess your understanding of those particular concepts. And once you're done, you can come back for the practice work that we'll now go through. If you want to get started with the practice work, we've provided the sample solution, a sample notebook that will allow you to be able to go through to go through now this particular course with ease. But if you would want to get more resources like challenges, etc., you can always consider becoming an Afterwork member, and you'll have all the resources as well as content, all other content in relation to data science or natural language processing that we have at Afterwork to your disposal. So take a moment, take about 10 to 15 minutes. Then once you've finished the quiz, you can come back and then we can continue. All right, so the next thing that we need to do is to go through the practice work. So open the practice notebook, and then once you have done that, you need to go to File, then save a copy in Drive, and this will save this particular notebook, a copy of it. You'll be able to save it in into your Drive, and then you should be able to make edits and save those changes. If you don't do that, then you won't be able to access the changes that you will have made if you close the tab. So do that. Once you have done that, the next thing that you need to do is to connect this notebook, the notebook that you now have, the new one, connect it to Google servers by clicking on the right hand side at the very top, just clicking on connect. Might take a few seconds to connect, and then we should get started. You'll see an icon that just looks like a check icon that will show up once it has connected. It just simply means that we're connecting this notebook, which is hosted on Google Drive, to just Google servers to be able to work, to be able to run our code. So that is done. So the next thing that we need to do is to work on just importing the libraries that we need. So there are a few libraries that we will need for this particular course for the practice work. The first library that we'll need is the data manipulation library, that's pandas. we'll use pandas to import data into our notebook, as well as be able to perform data manipulation tasks, just even the data exploration tasks, like checking the number of records in our data set, just previewing the first 5 or a sample of the records, just have a good understanding of what that data set entails. NumPy, we can use it to just perform some scientific computations. And that just allows us to be able to use some complex mathematical functions, yes, with pandas, that will allow us to just perform just mathematical computations. There's the regex library that allows us to perform text pre-processing, whether it's just cleaning data or removing some characters within our textual data. Then we can use the regex um, library for that. There's a string module library, if you want to call it that. You can also use it to work with strings. Maybe you want to replace some aspects of our texts with some other data, then you can use a string library for that. There's the natural language toolkit that we mentioned earlier. There's also another library, SciPy, that also provides us with just functions for just performing complex mathematical functions. So we'll import those particular libraries. If you see this pop up, just know that you haven't saved a copy in Drive. I don't want to do that because I already have a copy of this. I don't want to save any changes. The next things that we're going to do as part of the prerequisite is to just import a few details, a few other libraries for specifically performing natural language processing. So we'll start importing or installing Word Ninja as well as TextBlob. These are just going to help us be able to remove what are called stop words in our texts. These stop words do not necessarily add any meaning to the text, to any piece of text that we work with, and machine learning models may not necessarily perform optimally when we are working with stop words. And stop words can be words like is, there, those particular words that you find in a text, like joining words, they may not be helpful. So we import libraries to be able to remove and identify those stop words, to identify and remove them in the text that we are working with. We also import we also download WordNet, which is a data set that we can use to perform what is called lemmatization, and this process just refers to being able to reduce words into their root form. So if a piece of text contains maybe words like running, eating, then lemmatization will reduce those words into run, eat, which just helps us to focus generally on the word itself and be able to, and especially when you have multiple instances of those words, you can even be able to take that into account when you're creating machine learning models. You say import another library for a noun count. So this just allows us to be able to create new features that would allow us to be able to, again, create a feature that has the number of nouns in our data set. We also import this particular class, TF-IDF vectorizer, that will allow us to create a text representation of our data set. So our data sets by default would have textual data. So we would want to have that data in a numerical format that can be consumed by machine learning models, and that's where a text representation technique such as TDIF comes into play. So let's import those libraries. So this might take a few seconds. Once we have imported them, the other thing that we will need is to write some custom functions that will allow us to just, again, still continue performing feature engineering or creating new features. So we write a function in Python that calculates the average words in a particular piece of text. So we'll have lots of text, but again, we'll want to create maybe another feature or another column that contains average words. That might be useful. Maybe a machine learning model might get to learn something about that. We also define a dictionary that will allow us to perform what is called POS tagging. So that is what is normally referred to as part of speech tagging. So we might want to create extra columns, just again to be able to derive more information from the data set that we have, such as maybe a column that contains the number of um, um, uh, maybe it could be nouns, pronouns, verbs, adjectives. So that is what is called POS tagging. So determining how many of those, determining whether those particular parts of speech appear within the text that we have, and we can be able to also create now columns that describe how many of those particular parts of speech, whether it's adjective, adverbs, verbs, actually appear in those texts, and have that as new columns. For we might have a column for nouns, pronouns, verb, adjective, etc. And this function we use to check for the defined parts of speech tags that we want. We also define two other functions to be able to create, again, another column, one on subjectivity. So this particular column, we will have a new column that will tell us how subjective a particular piece of text is, and another one on the polarity of that particular piece of text. So the idea here is just to perform what is called feature construction, which is a technique in feature engineering that just allows us to create more data that we can use for training of our machine learning model. So we are sort of helping the machine learning model get more meaning out of the data that we have, the textual data that we have. We've covered this in texts in a feature engineering. We've also feature engineering course. We've also covered it in not only feature engineering but also in text wrangling course. So you might want to check that course for further details. All right, so starting off, let me just run this custom functions. You can also run that as well. The next thing that we're going to do is to import the data that we need. So we'll work. So this is the question actually. So we will need to create a classification model to classify new tweets with different sentiments given the following data set. So this data set contains tweets, it contains information about retweets, likes, as well as sentiment. So we need to create a classification model, train it based on this data, and then to be able to predict now the sentiment, whether that new piece of text belongs to has this particular sentiment or which is neutral or not. So this is how our data set looks like. So we used pandas in our situation there to check how big our data set is. That's how big it is. Sample size, that's our sample size, and there's also some other language in there that we may not necessarily know. Actually, this is not actually sample size. We're just getting a random sample of 5 records, or we can even do 10 records. Those 5, 10, you might want also to do that. And you can see how the data set looks like. We would also want to possibly have our data set be balanced. So we might want to get only, let's say you can see here we have positive, we have neutral, and negative. So we might want to work with a balanced data set, which means we might want to have maybe 50 records of random sample of neutral, maybe 50 of negative, or 50 of positive, so that we have a fairly balanced data set that we can work with. This is because sometimes machine learning models might learn so much about particular records, such that every time you give them new records, they would be inclined to make predictions towards that particular class. Maybe if they are more neutral, maybe 500 of them than negative and positive, the machine learning model might tend to predict records that are biased towards neutral. So we just want a fairly balanced one. We might want to even have more records, maybe even 200, 200, 200, here, but this is just for ease of learning. This is how we can be able to sample that particular data set. So we have a balanced data set, and we can preview now. We can perform data preparation tasks. This is just to determine whether the data that we have is has the right data type. So tweets has object data type, which is just textual or string data, which is okay. Retweets has float, likes, etc. They're okay. So we also check which of the values are in our target variable, which is okay. You can check for missing values, which we do not have missing values across those particular records, those particular columns. Once we do that, we can perform text processing techniques. We won't go into detail with regards to this particular section. The reason would be because we have covered this in another course, that's text wrangling with Python course, and our focus is majorly not on this. Our focus is on text classification. So what we are doing here, we're actually defining a text cleaning function that will apply to each and every record or tweets that we have, each and every tweet that's data. So we will first of all remove the URL link. So this is the code that we used for removing the URL links. Then later we remove @ and hash characters, and we replace them with just a space. We use the string module for that, str.replace. In our case here, we used regex. Then conversion to lowercase. So we convert the entire text into lowercase, again using a lambda function, as well as split function and a lower function. So here what we're doing is actually getting a piece of text, then splitting it, then applying the lower function, then joining that piece of text again. Then we remove our punctuation characters using regex, as well as the string module. Then we remove our stop words, as well as perform lemmatization. So whenever we call this function data cleaning, we're actually going to be performing these steps for just cleaning our data. We can then, after that, we then apply that function to our tweet column, which is this column, to be able to apply all those steps using the apply function, and then apply method, and then we sample the 5 records from that particular data set, which in our case we need to run this first, and then we can be able to run this. It may take, as you might see, it may take 2 to 5 minutes, etc., depending on your complexity. And this is the complexity of the data set. And this is what we can see. This is the final data set that we have after performing text cleaning. One thing to note is that text cleaning may also involve steps that haven't been mentioned here. Maybe you might want to perform spelling correction. Maybe you might want to convert some of those particular pieces of text that we saw were in another language to English, or the respective language that you're working on. So that is it. That's it in terms of cleaning. Then we will perform feature engineering. So what we want to do here is perform what is called feature construction, which is one of the techniques for feature engineering. What we're going to be doing is to create new records, new columns. So in this data set, we only have 1, 2, 3, 4 columns. So we might want to have more columns. One of the column we can create is length of tweet, another one, word count, word length, noun count, etc. And we use some of the functions that we had defined earlier for some of the tasks, like average word, POS check, get subjectivity, polarity, etc. And we're creating new pieces of text. So this particular function, feature engineering, will actually perform all those. We'll actually create all those particular new records, new columns. So we've done that. The next thing that we need to do is to apply that particular function to the tweets column. So we do that as shown. We can apply it as shown, or we could also do it as we did here. So just a way of referencing the same column. So this, again, as you see, may take 2 to 5 minutes. Sometimes it can take faster or less time. So I'll just leave it as is. as I explain the next thing. So once we have created our data set, which will contain multiple columns, we would want to, yes, that data set might have both textual data as well as our numerical data. But for the numerical data, what we might want to do is to create what are called text representations. So text representation would be an equivalent of some textual data set that we have. So what we will need to do is to actually create, perform what is called actually create what are called TF-IDF features. These are matrices that will be just representative of the actual text data set. So that's what we are doing in this other step that you see here. So we are using the TF-IDF vectorizer that we had imported earlier and defining a few resetting setting a few we're setting values for different parameters that you have for that particular in our case here this is a this is how we're actually creating an object, but we're also setting a just parameters, different parameters for that particular object when we are creating it. So we have max features, lowercase to true analyzer word. So this just tells us we want to perform what is called word level n-grams when it comes to creation of TF-IDF. I won't go so much into details with regards to this. We also cover this in text wrangling to just explain what word level entails. So we also still in relation to word level n-grams, we have n-gram range to just describe the range of the n-grams that we are working with. And here we also define that we also want to remove the stop words. We do that we create what is called a word level n-gram as well as character level n-grams. And we have now the result over here will be now two different matrices that we can combine together with the numerical data that we have, and then be able to perform some sort of and then be able to use that data to train a machine learning model for different tasks. So that's what we're doing. We're creating our two vectors. So we have this particular, well, it's a matrix as well as this other one, and we'll use now that is that. So yeah, so that's what we do. We also perform here what is called encoding. So for the sentiment column that we had initially, this particular column, we want to transform this into we transform it into categorical. So here in our situation here, we replace categorical values with numerical values as shown here. And this can actually be zero. You do not have to have it as strings. You could have it just simply as just numbers as shown. So for each representation of say neutral, it's going to be treated as a 0, positive 1, and negative as 2. So I think just to go back a bit, we have already created now our new records, our new columns. So we have new columns here. Let's perform other feature. Let's create the TF-IDF features, which we have, and then we perform labeling or encoding, so which we have. Then later we can also be able to select all columns that we have. So we want to select all the columns. When it comes to training a machine learning model, we have features and we also have a variable of interest, which is a label. Features would be all that we have and all the numerical columns plus the vectors that we have here, but we won't include the label. So here we are actually getting the other columns aside from sentiment and tweet, and saving that data into X metadata, which will contain now our features. This is just another way of just selecting the features that you see here, which is just a difference using a different function. difference function. Then we combine our two TF-IDF. So we combine the X metadata, which is now the numerical data, plus the TF-IDF matrices, these two of them. We combine them into now our features. So which we now have combined. So what we have is as an outcome is a sparse matrix. Once we have done that, we move on to data modeling, where we now create our machine learning model. But before we do that, note that we have now our features as well as our label, which is saved in Y. And before we do that, we need to split the data set into into 4. So we need to have a train X data set. We need to have training data set as well as a test data set. Training data set for training a machine learning model to make predictions, and the test data set will have data that we can use to evaluate how our model performed. So for the train data set, we split it into 2. We have the features as well as the label. So for the train, we have the features and the labels, and the test data set, the same case, features as well as the label. And we also we use the train test split function to create those data sets. And we pass the X, the features that we had initially, as well as Y. And then we also do the same thing. We want to define the size of our test data set, which should be 20% of the original data set or the records in X and Y. And also we set a random state to 42 so that we have reproducible results. Once we have done that, the next thing that we need to do is to import the algorithms, the machine learning algorithms that we're going to be working with. Initially, the first thing that we will do, we will import the base models, or just the common basic models that we can use. Then later we also import the ensemble classifiers, which are a combination of base models. You might have something like random forest, which is usually a combination of multiple decision trees. These are a bit more robust, but for just the learning process, we just want to see how all perform. So we import the classes that we can use to create those models, and then we instantiate them or create an object of those models. So we have now machine learning models that we haven't yet trained. So that's what we do here. Then later onwards, we train those models using the the features in the X in the training data set, as well as the values in the Y label for the trained data set. We do that for both ensemble as well as the base models. So let's run that for the training to happen. Here XGB is not classified. Okay, we don't need this. Let me just remove that. That's another model that we may not necessarily need. Let's just remove that. But you could always consider just also working with XGBoost if you want. So this is what we, so we've already done that. You get this output because this is the last classifier, so don't worry so much about that. Then we make predictions to just assess how our model performed. So we make a prediction for the X test data set, and then we compare the X test and the predictions and the Y test for just understanding how our model performed. We can now see how our model performed. The GBM classifier actually performed really well as compared to other models, as you can see here. By the way, please note that you might end up getting some inconsistencies if you work with this. You might end up getting inconsistencies because you might have a different random sample than I did here. So this is something to note. You might end up getting some different outcomes because your training data set would be different from mine, majorly because of the sample that I might have gotten there. But again, you could always consider when you're working in a real world project to ensure that you have some consistency. So that is what I have, 0.63. Yeah. Also to help ensure that you also have some reproducible results. You could also, if you are working on a project, such a project, and you want to share it with other persons, something you might do is just to prepare to ensure that your data set, the data set that you end up with, maybe at what particular point, at maybe at this particular point, before you perform modeling, is uniform. So whenever you're sharing your work, you should always have this particular data set as is the same. So you could always export it. All right. So I think from that understanding, we can use this the accuracy metric to just determine how our model is performed as shown. And this performed, the GBM classifier performed better than others. The least one was the SVM classifier, it's SVR or SVC classifier, support vector machine, SVM. We might want also to use a confusion matrix to just have a fairly in-depth understanding of how the models performed, as well as even printing out what is called a classification report that gives you an idea of other metrics, how also those other models performed. And basically from our outcome, we might see that possibly add a boost, maybe even just for ease of understanding, add a boost as well as GBM actually performed well, and that might be your recommendation. Our best performing models were Ada Boost, and you can now again perform other text pre-processing techniques, or even source for more data or increase your sample, and also perform other modeling optimization techniques such as performing hyperparameter tuning in order to improve the metric of the accuracy metric. So, and yeah, so I think that's it. At this particular point, you now have seen now the different steps that you can undertake in order to build a text classification machine learning model. Then you can use this for just any sort of text classification task that you have in mind. So the next thing would be to work on the challenges that we have given here. Just go through them. There are 4 different challenges. Work on those challenges, then verify your solutions with the solution notebook that we have provided. So for example, for challenge 1, we have that. Once you have done that, you can come back and then you can continue with the next steps. All right, so the next step would be to go through now this project, text classification with Python project. To get started, we've provided a guiding notebook that will provide you some details. You can go through, you can run the code for some of the areas. And whenever you get to an area of the section in the notebook that says your code goes here, you just need to apply those concepts. You can use your key lessons or some key lessons from the practice notebook, some code from there to just be able to apply it in these particular sections. And the idea is that you'll have a good understanding of how to apply those concepts in a real world project. Lastly, you can verify your solution by going through the project solution notebook that we've provided, and it should give you an idea of how you could have alternatively gone about your project. And that's it. And that's it with regards to text classification with Python. If you're looking towards now continuing your learning journey, you could look into some other workshops still related to this particular course in order to just get better and acquire this skill and familiarize yourself with how to work with just textual data for different use cases. Maybe it's for topic modeling, for even just if you want to just go back to text wrangling, there's a course on that. Maybe you want to perform sentiment analysis, there's a course on that, etc. So feel free to continue your learning journey. If you have any questions, feel free to also ask them in the chat, and hopefully your community or I will also be able to provide solutions to the challenges that you might be facing. All the best in your learning journey, and see you in a future course. Bye-bye.